Hi theory students. Today we're going to be reviewing how to calculate intervals. In this first part of the review, we'll be talking about how to figure out both the number and the quality of the interval. Just as a reminder, an interval is the distance between two musical notes. It consists of two pieces of information, a quality and a number. The number is by far the easier of the two to calculate. This is simply the count of the lines and spaces, starting by counting 1 at the first note and continuing the count for each line or space until you've reached the second note. Let me show you how this works. So if I had that note and that note, I could count the first space as 1, the next line is 2, the space is 3, the next line is 4, and then where the note is, 5, this interval would be a fifth. In this case, 1, 2, 3, 4, 5, 6, 7, 8. We don't call that an eighth, but in musical terms we call that an octave, which derives from the Italian word meaning eighth. The quality of the intervals is a little harder to describe, and there are procedures to show you how to do this. The first thing we need to do is divide into two different groups based on the number of the interval. So first calculate the number, and then you'll see if it's a unison, fourth, fifth, or octave, in which case it's in the perfect group, or a second, third, sixth, or seventh, in which case it's in the imperfect group. Each group has a model or comparison quality for that group. Think of the model as a kind of measurement or yardstick against which we'll be comparing the actual interval that we're looking for. So the model for the perfect group is a perfect interval. We would say a perfect fourth or a perfect fifth. The model for the imperfect group is the major interval. So we can have a major second or a major third. We can't have a major fifth. We can have a perfect fourth or fifth. We can't have a perfect second. Let me show you one way to find this model. And using this method, if the higher of the two notes is in the major key of the lower note, then depending on which group it's in, it's either perfect or major. I'll demonstrate a few of these. So let's say we have an F and a B flat. If B flat is in the key of F major, then this would be a perfect 1, 2, 3, 4, perfect fourth. B flat is in the key of F. F has one flat in the key signature, so that's a perfect fourth. Here's another case, and this is bass clef, remember. So we'll ask the question, is E flat in the key of C? It's not. E natural would be in the key of C, so that's not a major third. That is a major third. Let's look at another case. Is F the higher note in the key of A flat major? Yes, it is. A flat has 4 flats in the key signature, but F is natural. So that's a major sixth. So, Good enough if the bottom note has its own major key, but what do we do in an instance where, for example, we don't have a key of G sharp major? So how do we evaluate this? One way to do this is to take both of these notes down a half step. Think about it. If I move both of them the same amount, the distance between them hasn't changed. So now I could do this and say that C is in the key of G, so therefore that is a perfect fourth. If that's a perfect fourth, then so is that. This is the principle that I just demonstrated to you. Whatever you do to both notes, if you do the same thing to both together, it doesn't change the distance between them. So then you can calculate it on that basis. So here are some examples of perfect or major intervals. From G up to B is a major third. From E flat up to B flat is a perfect fifth. From A up to G sharp is a major seventh. From C sharp to E sharp is a major third. And this one's a little trickier, but from D sharp to F double sharp is also a major third, because that's the same distance as D natural to F sharp, which is the same notes a half step lower, and this is a major third, so therefore so is that one. So now we have our model interval, the perfect or major interval. Now that we know what that is, we can compare it to the interval that we actually have. And here's a chart that'll help the comparison. If we know the perfect interval, the augmented interval is a half step wider. The diminished interval is a half step narrower. Let me show you an example. So if that is a perfect fourth rather, that's a half step wider, and that's an augmented fourth. That's a half step narrower, and that's a diminished fourth. If that's a major third, that's a half step wider, that's an augmented third. This is a half step narrower. Is that a diminished third? No, this is in the imperfect group. In the imperfect group, the augmented's a half step wider than major, but it's the minor that's a half step narrower, and the diminished that's 2 half steps narrower than the major interval. Let's go back to the other example. So this would be a minor third, this would be an augmented third, this one is our major third. If I wanted a diminished third, I would have to make it a half step narrower once and twice, and that would be a diminished third. This is what I just explained to you. Above the model interval is a half step wider. Below is a half step lower than the model. Half step wider, a half step narrower. And in the imperfect group, a half step wider, a half step narrower, and now 2 half steps narrower. You could also measure intervals by counting half steps from the lower to the upper note. Picturing a piano keyboard may help you do this. Here in this chart, and I'll show you an example in a minute, a minor second consists of 1 half step, a major second 2 half steps, a minor third 3 half steps, a major third 4 half steps, and so on all across this chart to where a perfect octave is 12 half steps. So here's a piano keyboard. So starting on F, if I go from F to G flat, that's a minor second. If I go from 1 2 half steps, F to G natural, that's a major second. 3 half steps to A flat, and that's a minor third. Add another half step, that's a major third. And you can see how this works all the way up. Picturing the keyboard will give you a good idea of the half steps. There are some advantages to this. It's a consistent and easy way to count. But there are some disadvantages as well. As the interval gets wider, counting all of these half steps gets more cumbersome. Think of it like trying to count on your fingers if you're doing arithmetic. Also, just as there are enharmonic notes like C sharp and D flat that occupy the same key on the keyboard, there are enharmonic intervals like the minor third and augmented second, each of which consist of 3 half steps. So counting half steps may help for seconds or thirds, but as you get wider than that, it slows you down eventually and gets more problematic. So you should be able to learn how to figure out the interval either way, from the major key model or from counting half steps. That's the first part of our interval review. In the next part, we'll be talking about inversions, compound intervals, and a shortcut for trying to figure out which intervals are major and which intervals are perfect. That's all for today.